Hello everyone, I'm Sadie Bogart and I'm here with Alicia Rivera, my research partner, and this is our presentation for the 2020 Watershed Symposium. We're from Salt Lake Community College and our project is on high resolution spatial and temporal water quality sampling on the Jordan River from segment 2 to segment 6. A brief overview: the Jordan River has been listed as impaired by the Utah Division of Water Quality per the Clean Water Act's 305B and 303D list. The river is impaired for dissolved oxygen, total dissolved solids, and temperature. Segments 1 through 3 are impaired for DO. Segments 1 to 2, 4 to 6, as well as segment 8 are impaired for TDS. Segments 5 to 7 are impaired for temperature. Our study is focused on providing large data sets to narrow down areas of impairment and their possible causes.
A total of 518 samples were collected at 84 predetermined locations seasonally between 2018 to 2020. Winter data was sampled in January, spring in March, summer in August and September, and fall in October. Samples were taken over a week-long period each season owing to good weather conditions. Data was recorded using the HI 98194 multi-parameter waterproof meter to test for dissolved oxygen, temperature, and total dissolved solids from the riverbanks or bridges when possible, using a bucket or extender bar to collect the water samples. 147 of those samples were above the total dissolved solid standard. A total of 20 samples from summer 2018 and 2020 show dissolved oxygen readings below the Utah Division of Water Quality standard. Samples at 4 tributaries flowing into the Jordan River from Mill Creek, Little Cottonwood Creek, Big Cottonwood Creek, along with a canal, do show significant differences and have been seen to affect the Jordan River data.
Moving on, we are going to show the graphs and discuss what is going on in each of them. So for spring, we have total dissolved solids. And here we see drops in segment 4 at the confluences. That's where we have Mill Creek confluence, the Big Cottonwood Creek, and then Little Cottonwood. Spring does show an overall decrease in TDS as we move downstream. Samples in segments 4 to 6 are most frequently seen above the TDS standard of 1,200 parts per million, with the exception of 2019, which does not spike above the maximum. Moving on to DO, we see dissolved oxygen and temperature shown together to highlight their relationship. As you can see, temperature increases as DO decreases and vice versa. This data indicates that DO is above the UDWQ thresholds in all but 2 samples. For spring and summer, we have the minimum requirement being 4 parts per million, and then for fall and winter, we have it being 4.5 parts per million. So in all but 2 samples for spring, we see that they are above the minimum requirements. Dissolved oxygen does increase as cold water effluent joins the Jordan River in segment 4. DO then continues to show a decreasing trend downstream.
For the summer total dissolved solids, a total of 75 samples were taken in summer of 2018 and 2020. Summer of 2018 showed 20 samples above the maximum TDS in segments 5 and 6, whereas 2020 did not. For the summer sampling for dissolved oxygen and temperature, it shows the most impairment of all collected seasons. Sampling shows 20 out of 75 samples failing to meet the minimum requirement for summer dissolved oxygen, and 53 out of 75 above the maximum temperature standard set by the Utah Division of Water Quality. Summer is the only season to show the impairments through most of the river data sets.
Moving on to our fall data. So 46 samples for fall indicate TDS levels above the maximum. TDS does show a decreasing trend downstream with similar spikes located in segments 4 to 6 and drops in concentration at the tributaries. For dissolved oxygen and temperature, we have the data showing that there were no samples reported below the minimum. An increase in DO, however, was noted as an overall trend downstream. Our winter TDS data shows the most differences between the years sampled. As we can see, 2019 and 2020 are more or less showing an opposite recording in segment 2 and 3, and then a little bit in segments 5 and 6. So for TDS in the winter, we see 67 samples being above the TDS standard set by the UDWQ. Most of these were from 2019. We see segment 4 showing similar dips at the tributaries as other seasons, and segment 6 showing the same increase in TDS as seen in all the other seasons sampled. For dissolved oxygen and temperature, we see that winter dissolved oxygen shows no samples taken below the minimum standard set by the UDWQ. A decreasing trend downstream with spikes at the tributaries were noted.
So in conclusion, most seasons show similar increases in environmental parameters at section 6 and decreases at the confluences in section 4. Spikes in temperature and dips in dissolved oxygen most often occur in segment 5. There is a water treatment facility located in the area, so there may be a correlation between the facility and the river impairments. Further research is needed. Urban area runoff and water treatment facilities seem to be the most likely cause for the high total dissolved solids. This is especially noted in the differences in trends identified for both winter sampling sessions. Summer needs to be further studied for causes of low dissolved oxygen and high temperature. However, likely sources is lack of riparian growth along most of the river, incised meanders, along with water treatment facilities. Overall, this study does need to be continued to provide further data sets to continue to look for trends. And we would like to thank Salt Lake Community College along with the University of Utah for providing the research grant opportunity with the National Science Foundation. Thanks also go out to all the students who helped collect the data. And this is the end of our presentation. Thank you.